Okay, this is the mind map for the periodic table chapter. Now the first thing is, let's start from the top. Elements in the periodic table are arranged in order of increasing atomic number or the proton number. So in the periodic table, you can see that the proton number is the bottom number. Okay, it's not very clear. So for example, the first element is hydrogen. Now the bottom number, which is the atomic number or the proton number, okay, so for hydrogen is 1, and then the second element is helium and the proton number is 2, and then 3, 4, 5, 6, so all the way increasing. So that is why the elements in the periodic table are arranged in order of increasing proton number or the atomic number. So the bottom number is the proton number. For example, for this element here, boron, the proton number is 5. Proton number also known as atomic number. The top number is called mass number, or it is the number of proton plus neutron. Now mass number also known as nucleon number. So all these are proton number, mass number, nucleon number, atomic number. All these you should have learned it under the atomic structure chapter. Now let's go back to our periodic table. Now for periodic table, you need to know that the vertical columns are known as the groups. Okay, so this is the vertical columns. So all these are groups, and all together there are 8 groups. And that is group 1 to group 0, and group 0 is also known as group 8. Okay, this is group 1, 2, 3, 4, 5, 6, 7, 8 or 0. Now you have to take note that the group number is in Roman numeral. It's not in our normal way of writing number. This is a Roman numeral. For example, III stands for 3, and then IV stands for 4. So you have to be very familiar with what all these Roman numerals mean. Okay, group 1 to group 8. And the same group means same number of valence electron. So elements in the same group. Okay, for example, group 7, we have fluorine, chlorine, bromine, iodine. So all these elements here, they are all in group 7. Now they are all in group 7, meaning that they have all these elements, they have 7 valence electrons. That means 7 electrons in the outermost shells. Okay, so same group means same number of valence electron. So all the elements in group 7, they should have 7 valence electron. Likewise for all the elements in group 5, like for example, group 6, for example, oxygen, sulfur, they should have 6 valence electrons, or 6 electrons in the outermost shells. Okay, same number of valence electron, and same number of valence electron means that they have similar chemical properties. Now you have to take note that the chemical properties of an element really depend on the number of valence electron that the element have. So if I give you 2 elements and they have the same number of valence electron, and these 2 elements should have similar chemical properties, meaning that they undergo the same type of chemical reactions. Now, same number of valence electron, this is an example, elements lithium and sodium. So lithium and sodium, if you look at the periodic table, they are in group 1. Okay, lithium and sodium. So they are in group 1, meaning that they have 1 valence electron. Okay, that is why over here they have 1 valence electron. Now 1 valence electron also means that the valency is 1. Now valency is a new term here. What is the meaning of valency? Valency basically is the number of electron an element needs to gain or lose in order to be stable. Now group 1 element, they have 1 valence electron. So in order for them to be stable, they have to have 8 valence electron. So now they have 1. they need to have 8. So the best way is to lose the valence electron, then become 8. Okay, an example here would be, in order to have a clearer picture, we can draw out the electronic configuration, the electronic structure of, for example, lithium. Now lithium is in group 1. So your lithium, the electronic structure should be like this. Now it is in period 2, means that there are 2 electron shells. Okay, 1 electron shell, 2 electron shells. Okay, and lithium, it has 3 protons, meaning that it has 3 electrons. So 3 electrons, the first electron shell should have 2 electrons. The first electron shell can accommodate 2 electrons. Now it actually has 3 electrons, right? So 2 electrons here, so the 1 remaining electrons would be the valence electron at the second electron shell. Okay, now in order for lithium to be stable, this is very unstable, because the second electron shell can the second electron shell need to have 8 electrons in order for it to be stable. So this lithium atom is not stable. Now in order for this lithium atom to be stable, it needs to either lose this valence electron, lose this 1 electron, or to gain 7 more electrons. Okay, so that it has 8 valence electrons. So the easier way is to lose the 1 valence electron, because losing 1 valence electron is easier than gaining 7 electrons. Okay, lose 1 is easier than gaining 7. Therefore it will lose this valence electron. Okay, so this is, so it loses 1 electron, right? That's why the valency is 1. Okay, number of electron an element needs to gain or lose in order to be stable. So whenever the question asks you the valency of an element, you just think of how many valence electron it needs to gain or lose in order for it to be stable. Okay, so this is about valency. You have to remember the meaning of this term called valency. Now let's look at period. Now period is a horizontal row, okay, the horizontal from left to right. So period 1 only has hydrogen and helium. Okay, that this is the most common mistake that students make. They thought that period 1 is this period. So period 1 in fact is the hydrogen, is a period containing hydrogen and helium. Okay, period 1. So altogether it has 7 periods, and it is from period 1 to period 7. And in this case, the period number, it is in our normal Arabic number, not in Roman numeral. Okay, 1 to 7. Now same period means same number of electron shells. So for example, lithium, it is in period 2. It means that it has 2 electron shells. Okay, like the electronic structure that I drew just now, it has 2 electron shells. Why? Because it is in period 2. So the period number is the same with the number of electron shells. Period 3 means 3 electron shells. Okay, same number of electron shells, so same period means same number of electron shells. An example would be lithium and beryllium. Beryllium is here. Okay, and both of these elements, they have 2 electron shells. Why? Because they are in period 2. Now let's look at the trends here. Now basically for this chapter, we only studied about the trends of the periodic table. It is not our intention to go and memorize every single elements in the periodic table, because we can always refer. We have periodic table to refer to during exam, so we do not need to memorize all the elements. We need to study the trend, the pattern. Now as you go down the group, all the groups are, as you go down, go from top to bottom, what happens is the proton number increases. Okay, because you look at the bottom number is the proton number. Okay, as you go down the group, the proton number increases from 3 to 11 to 19 to 37. So the proton number increases, and it also means that the size of the atom increases, because when the proton number increases, proton number actually is the same with the number of electrons. Okay, So if you have more and more electrons, you need more and more electron shells to accommodate the electrons, so it become bigger and bigger. So lithium is like this, your sodium would be like this. Okay, your sodium would be like that, because your sodium is in period 3, meaning that it has 3 valence, 3 electron shells. So sodium will be bigger than lithium. Okay, so size of atom increases and metallic property will also increase. Why metallic properties? Now this metallic properties depends on how easily the element lose the electron. Okay, remember how metallic an element is depends on how easily an element loses an electron. If the element loses electron very easily, that means it is very, very metallic. Now let's compare lithium and sodium. Now both lithium and sodium, okay, let me draw the electronic structure for sodium. Okay, so sodium would have 8 valence electron, 8 electrons in the second electron shells. Okay, they are not connected, lithium and sodium, and like that. Okay, so sodium has 1 valence electron, lithium has 1 valence electron. Now in order to find out how easily the element loses electron, you look at how far the valence electron is to the nucleus. The nucleus has proton. Proton is positively charged. Electron is negatively charged. So the electron, or in this case the valence electron and the proton, always attract each other. Now for sodium, the valence electron is very far away from the nucleus, because the valence electron is at the 3rd electron shell. For lithium, the valence electron is at the 2nd electron shell, so it is closer to the nucleus, meaning that when it is closer to the nucleus, the attraction between the proton and the attraction forces between the nucleus and the electron and the valence electron, okay, is stronger as compared to the attraction forces between this nucleus and this valence electron. So when this attraction is stronger, meaning that it is harder for lithium to lose this valence electron. Yes, I explain one more time. For lithium, the valence electron is in the 2nd electron shell, meaning that it is closer to the nucleus, meaning that the attraction forces between the nucleus and the valence electron in the lithium is stronger, and it means that it is harder for the lithium to lose this valence electron. Okay, and for sodium, it is easier for this valence electron to be lost because it is further away from the nucleus. Therefore, sodium is more metallic than lithium, because sodium loses the electron more easily. So when the sodium loses electron, it will become Na2, Na+. When this lithium loses electron, it will become Li+. Okay? So if we compare lithium and sodium, sodium is more metallic than lithium. Why? Because sodium loses the valence electron to become Na+ easier as compared to lithium. Therefore, it is more metallic. Okay. Now let's look at the transition metal. So this block here, without any group number, they are called transition metals or transition elements. They have more than one oxidation states and they form colored compounds. That means, for example, when iron, Fe is iron, when iron form a compound, for example, iron oxide. Okay, when iron form a compound, that means it combines with other elements. Okay, an example would be this compound here. So when iron form a compound, and this compound is colored. Okay, this compound has a color. that is called colored compounds. And all the compounds formed by elements in the transitioned metals, they are all colored. They all have color. Now, just now we look at the group going down the group. Now let's look at the period left to right across a period. If you go from left to right across a period, you can see that the metallic property actually decreases. Why? Because there is a staircase here. Okay. So all the elements, all the yellow color elements, they are all metal. All the blue color elements are non-metal. So as you go from left to right, you are actually going from metals to non-metals. That is why there is a decrease in metallic properties and there is an increase in non-metallic properties. And of course the size of atom would decrease. Okay. Now let's look at metalloids. Now these metalloids, they have both metallic and non-metallic properties. Okay, all these metalloids are basically the elements at the staircase. Okay, be very careful with aluminium, even though it is next to the staircase, but it is not a metalloid. It is a metal. Only the circle elements are the metalloids, and there are 7 of them. Okay, and the metalloids are also known as semiconductors. Alright, let's go to page 2. Page 2 of the mind map. Now, for periodic table, we study more in depth for group 1, group 7, and group 8 elements. Okay, the other groups we don't really study more. We don't really study in depth. Now, from the previous mind map, we learned that reactivity actually increases as you go down the group. Now, let's talk about it later, this part. Now, group 1, alkali metals. Now, group 1 elements, another name for it is alkali metals. So all the group 1 elements, they are also known as alkali metals. Now, why are they known as alkali metals? Because they react with water to form alkali and hydrogen. Okay, an example here would be here. Okay, chemical properties. Group 1 elements, they are very reactive, meaning that if you take out the if you expose the group 1 elements to the air, there will be reaction because the air has moisture. So group 1 elements are very reactive, and because of that they have to be stored in the oil. Okay, because obviously water cannot dissolve in oil. So alkali metals plus water, you get alkali and hydrogen. So you have to remember this. The products that would be formed when alkali metals react with water. So this is an example. Sodium and water react together, they will form something called NaOH, or sodium hydroxide, as well as hydrogen. Now over here, reactivity increases going down the group. Why? As you go down the group here, just now we learned about atomic size increases or metallic property increases. Now, as you go down the group, also the reactivity of the metals also increases. That means the most reactive element in the group 1 elements, among the group 1 elements would be francium, and then followed by CS, stands for cesium, and then rubidium, potassium, sodium, and lithium. Why? Why does the reactivity increases going down the group? Because as the size of atom increases, because as you go down the group, the size of atom increases, right? Now when the size of atom increases, it is easier to lose the valence electron. Okay, just now we talked about this. When it is easier to lose the valence electron, when the alkali metals loses valence electron, it becomes what? It becomes an ion. Like for example, sodium loses valence electron, becomes sodium ion, and this sodium ion, because it is charged, so it must combine with other elements. It must combine with something to form, like for example, NaX. That is why it's so reactive, because it will react with other substance to form a new substance. Okay. All right.